Build Science 301, a Build Original series brought to you by Anderson Windows and Doors, Arkland, and Huber Engineered Woods.
Hey friends, Matt Reisinger here, and if you've followed me for any length of time, you know I'm big on performance, durability, and smart building solutions. Now when it comes to windows, Anderson has been the go-to for decades. Builders like me and homeowners who care about quality know the name and trust the product. Now in our Build Science 301 series, we're diving deep into one of the most impressive innovations I've seen from Anderson. It's called the Easy Connect joining system, and it's a total game changer when it comes to installing large window combinations. Instead of wrestling full frame heavy units into place, Anderson sends factory assembled sub-units ready to drop into your rough opening. They use interlocking fiberglass joining plates so you can connect units vertically, horizontally, or both with both precision and strength. Now, what does that mean in the field? Fewer crew members, no heavy lifting equipment, and way easier install handling. You get big window impact without the big window headaches. Even better, this system delivers incredible design flexibility without compromising structural performance. It's AMA 450 tested, Hallmark certified, and even HVAC approved when you pair it with Anderson's A-Series windows and reinforcing joining options. Air-water structure, this system performs at the highest level, while saving time, boosting install quality, and helping you build smarter, not harder. Want to see it in action? Go check out how Jake Bruton used it at one of his builds. You'll find the full video over at andersonwindows.com. Simplify your builds, strengthen your results. That's the kind of smart building science we love sharing here on The Build Show. I'm Matt Reisinger, and thanks for watching. I'll see you next time on Build Science 301. All right, my friends, welcome back to Build Science 301. We got a really fun topic today. We're going to be talking about staggered stud walls and double stud walls, meaning thick framed walls above grade. Where do you want to start on this, Steve?
I want to talk muscle cars.
Okay, all right.
So muscle cars, right? Everybody loves them, the Chevelles, the Javelins, Mustangs, you know, nice engines in them. I'm not a car guy, so I have to speak really a high level of that stuff. But the difference between, say, a muscle car and the Pacer, right, was it goes fast. It's got a little bit more oomph to it. It's performing a lot more.
Yep.
Well, what we're going to talk about today, I would consider these aren't the drag racers. They're the muscle cars of the building industry.
Interesting. All right. I like the analogy.
Let's get
in other words, higher performance, but they still look like standard construction.
And there's still another level we could take these to that we're gonna.
Okay.
But this kind of is next level, a little bit more performance.
Okay, cool.
So, staggered stud. What is a staggered stud? Very simply, we could do a wider plate. You could do a 2x6 plate here. When I do them, I typically do a 2x8 plate.
Okay.
And we basically do 2x4s, 24 inches on center, and interior 2x4s, 24 inches on center. And you can see we have continuity of insulation through here. So we don't have any thermal bridging.
We have a continuous top and bottom plate, but the studs are not.
We have some there.
Yep.
You know, down here, it's very similar to the walls that we just looked at. We just have simple sheathing on the outside because we're putting the performance, we're relying on it on that double stud wall.
Yep.
So we're not putting it on the outside. And then for the double stud wall, all we're doing is we're basically putting a break in the wall there and splitting it. And the beauty of the double stud wall that I really like, especially when you're doing passive houses, right? This can start out at 9 inches, but it could go to 16 if we wanted.
Wow.
Right? So you have the ability to just move that outside wall in and out and take this and move it. So that way there you can really tune it to what we need for the requirements of passive house. If 9 inches doesn't make it, let's bump it to 10 and see if we can do that.
Makes a lot of
sense. And then
it
solves for it. This one here, you're kind of locked into either a 2x6 or a 2x8. I mean, you could probably do 2x10, but before I did 2x10, I'd go over and do that one.
As a bit of a confession here, I've never built one of these assemblies for an exterior wall, but we have done a lot of staggered studs on interior walls for sound reasons. Like on the house that Steve designed for us, the Reisinger build, Steve put staggered stud walls in several places, like between the primary bedroom and the hallway. so that we could have some reduction in sound transmission. So it is becoming more common to see these, but these exterior walls, at least in the South, I don't see a whole lot. This tends to be a more northern detail.
Yeah, and there are other places. I met with a builder, you probably know Shane out in California. He builds literally right under a flight line.
Oh, wow.
And so all of his exterior walls are double wall because of the acoustical properties of that wall system. So
makes a lot of sense.
It's a great point that you brought up, that not all performance is totally based on energy. It can be acoustics and comfort due to sound.
What's the challenge, Steve?
The challenge is we get overwhelmed here.
Yeah, there's a lot of lines here.
Yeah. So water, again, #1 killer on both of these. So we always have to deal with water, right? #1, we'll put it there. And I know we might have mentioned it in one of the earlier series, but our good friend Jake Bruton, he actually did a little research and went online and typed in what is the #1 reason for litigation in residential buildings. No surprise, it was water.
I saw a stat a couple years ago that I used in some of my presentations that was from the AIA that was like 82% of construction litigation is water related in some form or fashion.
Yeah. And there's still people out there that think that they can confront and beat Mother Nature. It's baffling.
Nope.
#1 killer, got to deal with water. Once we're done with water, let's talk a little bit about air. Air across here, air across here, air across the wall. What's our primary air barrier? And again, when you're talking about things like, okay, we're going to use zip sheathing out here, that's our primary air barrier, or we're going to do plywood and maybe a CMI vest or something that gets adhered to it. It's not that one is better than the other. The understanding is you have to understand what are the limits of the decision that you're making and what are the pros and cons of those decisions. And then that kind of propels you to what's the right decision.
Yeah, that's a really good point. And as a side note, I do see a lot of high-end builders doing something like 3/4 sheathing, 3/4 plywood, and then doing some type of peel and stick. In the South, that might be Polyguard's Alumiflash. In a more northern climate, that might be something like Dorkin's Delta Vent SA. So that now I've got a really thick sheathing, which gives you some other advantages too. We won't get into a ton of that right now, but it gives you the advantage, for instance, of being able to put a fastener just about anywhere on that wall and having some thickness or some meat, especially when we think about brick ties and that sort of thing. The point here is there's a lot of different assemblies, a lot of different materials, but we really need to understand the science of what's happening and what are the forces that are interacting on those walls.
Yeah, and with a couple of custom builders, and you went out to the one house that we did with Howell where we did 1/2-inch Advantech. And the reason we chose Advantech was it was a very large house. Well, the exposure time of the framing of that house, it's not the same exposure that, say, a 1,800 square foot house sees.
Great point.
Right? The cladding might go up in 4 weeks on a 2,000 square foot house. It might be 3 months that the house is exposed to the weather before you get cladding on. So there's a lot of different decisions that you have to bring into that game as far as the durability there. Drying, well, it's all the same here. Drying through there, drying through the wall. Now, because we have a thicker wall, that's going to be a different game changer in how things move through the wall as far as an energy perspective. And then, of course, insulation. How do we deal with insulation through there? And even though we pack it in there, a lot of insulation isn't necessarily a good idea when the decisions are for the wrong reasons.
Good point.
So double wall, pretty much the same here. We have our insulation there, we're going to have some kind of there, and then we have to deal with something there. Now, one of the things we didn't touch on, and I didn't put the solution, but when we talk about the solution, we should touch upon some people do it from the outside. And there's a couple die-hard people that always beat me up about, oh, you should insulate it from the outside. So we'll have that discussion when we jump to that. So water, again, rain screen. I'm not going to draw my little detail there, but we need to drain. And Joe would say drain on the plane, and we need to dry. Drain down, dry up.
Yep.
And that happens behind the cladding. As far as airtightness, we've kind of beat that horse, but we have that. We have the mastic that you like, or the tape there. Another system, Protecto Wrap, actually makes a T-shaped one.
Oh, really?
That you can tape to this wall, tape to that, leave the flap down, and then when you sheath it, you flip it up and tape it. So that's been around for quite a while.
Interesting.
But there's a lot of systems there. As far as the sealants, I know we talked about Sashco, Lexel. They also make Big Stretch. I haven't tested out the Big Stretch to understand. We use the Lexel. We've also used Tremco acoustical sealant there, which is a fabulous material for that because it never hardens. It always stays elastic. And then as far as air barrier, right? We have our sheathing here. This could be a zip sheathing, and that's our primary air barrier. Or like we said, we could do a 1/2-inch CDX and put some type of membrane on there. Right. And then as even a further option, I have seen some people put up CDX and then use like a Siga Fentrum tape and use the plywood as their air barrier.
Right, so if you wanted to use, let's say, a standard house wrap, just a mechanically, stapled, then that's when we might switch to using a tape at the plywood. So the plywood faces the air barrier. I'm not a big fan of using house wraps that are mechanically applied as air barriers. I think that the future really is peel and sticks or integrated or fluid applied. So you're going to see Steve and I mainly talking about those as primary air barriers on the outside of buildings.
Yeah, one of the things that I'm really surprised at, believe it or not, probably 20 years ago, me and the Yost brothers got called into by a large chemical company, and they were going to try and develop like a spray-on building paper.
It's interesting, the commercial guys are doing that more and more, are doing spray-applied WRBs. There's a lot of options out there, but one that I've seen on our jobs is either Prosico or Polyguards, and they make them in different viscosities, a sprayable viscosity, a rollable viscosity, or one that we can gun out, and it's all the same chemical property. I think that in the next 10 to 20 years will make its way more and more into residential, but there's an adoption period on that. Guys, if you don't know Huber Engineered Woods, this is the manufacturer of products that I have used nearly my entire building career. Think about Advantech sheathing that they make. Gosh, I started using it almost 2 decades ago, and that has been my go-to for a bomber subfloor that totally takes the elements, especially the rain, through the years. And they're also the maker of the zip system sheathing that I used on my own house. You can learn more on their website, but this is a fabulous company with some bomber products.
So I'm going to hit you up because say I wanted to do this building assembly right here in Austin and I wanted to do a passive house. I can handle the wall, but I know here you have extensive experience where you put the plywood up and then you put that foil or Alumaflash. Right? So why don't we talk a little bit about that for our southern builders?
Okay, so in the south, we don't want anything stopping drying to the inside. We don't want any vapor barriers on the inside because really 10 months of the year and minus a couple of days, pretty much everything's drying to the inside. For the most part, our temperatures in the house are 70 degrees and we're air conditioning because it's hotter outside. And as a result, the vapor drive is 99% of the time towards the inside of the building. And so remember that water is our #1 enemy. A lot of builders in the south in particular, climate zone 3A and below and lower than that, have said, okay, we can put a low or no perm WRB on the outside, like Polyguard's Alumaflash. Actually, it's not called Alumaflash. It's UV240 now. I apologize. I'm using the old name for it. It's a aluminum-faced peel and stick, 40 mil. And so that aluminum doesn't have any perm rating. It's a 0 perm. But what I like about it is it's a really, really good water barrier. It's literally a barrier. And then inboard of that, I make sure we don't have anything that would stop things from drying to the inside. I'm always using vapor permeable insulations, those types of things so it can dry to the inside. Because again, water is my enemy. And if I deal with water first, almost everything comes into play, kind of falls into place after that in my climate where it's hot 99% of the time.
Yeah. And so moving north into the northern climate, especially when we talk about insulation, we talked about this enough in the previous where we could do an unfaced bat. We want to do something there that's hydrophobic. There's a lot of insulations that are made to go onto the wall. Subterra is one of them that we've used. Here, I chose to show an inset piece of rigid insulation for somebody that wants to try and minimize the amount of foam. So we bring that band joist, we push it in 2 inches, and then we can insulate it on the inside also. And then we still have the same structural integrity happening there, and then we can minimize and just make a small connection with insulation there. But moving up to the northern climates, especially, climate zone, say 5 and higher, the higher you go, the more risk you're at with this detail, because as vapor moves through here, understand there is a lot less energy warming that surface than a 2x4 or a 2x6 wall.
That's a great point.
Right? So when it's 70 here and it's 0 degrees here, well, on a 2x6 wall, maybe the inside of that is 55 degrees. If I start putting a lot more insulation, the understanding and the risk that I put myself at is this surface might go from 55 down to 45 or 40. And remember, condensation is a game of 1 degree, right? 41 degrees if it's dew point, I get condensation. 42 degrees, I don't get condensation. It stays vapor.
That's a great point.
So 10 degrees, 15 degrees, that's a pretty big delta. Now,
significant.
You sit there and say, wow, I got all this insulation, I'm going to be a super energy efficient house. But the reality is you might be putting at risk where it's going to rot in 3 years, and the energy bills really don't matter at that point. So you have to understand, the abacus of building science. For every great thing you do, you have to pay attention to some other things, right? Joe says no thermodynamic lunch is for free, or he has some kind of comment that goes with that. But anyways, any other comments on staggered stud?
No, that's great.
All right, let's move on to double stud here. Because the double stud, all this does really, all of this is the same down below. And then you can see I did the inset, but the real game changer up here is what's happening across here for vapor. Obviously, we can make that 10, 12, 14 inches wide, which means I get a super energy efficient house that I can light with a candle. But if this is say a 1,800 square foot house with 5 occupants and 2 dogs, I get a pretty high moisture content on the inside. So I have to deal with that. On a 4,000 square foot house with 2 occupants, yeah, maybe I'm not really that worried about it.
Adding that much moisture load to the house.
Exactly. And
interior moisture load, that is.
One of the things about, this wall system also, that if you have an outlet here, say, and you get air leakage through here, well, the amount of moisture that can go on the air train is an order of magnitude to the amount of moisture that will diffuse through that wall.
That's right.
So we really want to make sure that our air leakage across that assembly, we'll talk air leakage numbers. This is my personal scale. 1.5 ACH 50. That is our target. If we do better than that, I say, okay, 1.0 I think is a very good job. And 0.60, which is passive house, is a great job. So that's how I look at it.
And those are blower door scores. If you haven't talked about that yet, we're talking about how air leaky the building is, and that's the score for it. It's interesting, this is a bit of a side note, but I would tend to agree with you on these. 1.5, that's a good score. 1.0 is really what we should be as builders moving towards over time and below. If you get 1 and below, you're in the top 0.0001% of houses that were built last year in America. In passive house, fantastic score. 0.7 is still a fantastic score as well. And if you get down to a 0.2, that's great and all, but we need to be a little cautious. Anything
when
below
you get
one,
below
really,
this number, I start questioning, you have to question, was the fan calibrated? Who did the testing? Who did the calculation? Because I've heard some crazy numbers that I don't quite believe.
I totally agree.
And it's like, that's why I stop at 0.6. You get below 0.6, 0.4, 0.5, 0.3, they're all the same number to me.
That's right. And these numbers, by the way, I think, Steve, are a particularly good number because that's a number that works throughout the country. In my mind, whether you're building a house in Maine or whether you're building a house on the tip of Florida, you still want airtightness. Now, the issues that come with air leakiness are different. In Florida, that means we've got a lot of moisture coming into the house because we've got air leakiness and a lot of hot, humid air. In Maine, it might be really cold, freezing air in the wintertime, but there's a lot of issues that come with air leakiness through the house. So we want to build that tight house. And then later, we'll be talking about ventilation. We want to bring that fresh air in on our terms, and we want to filter it, and we want to move the moisture in it, and we want to move the heat in that air. There's a lot to talk about there, but ultimately that blower door score, that air tightness that we're talking about here, makes a huge difference in the durability, the efficiency, and the longevity of that house.
Yeah, and I just want to, because I have a house in mind that we did the calculations. Really, I knew the guy that did them, but then we did kind of some examples. So we did this one house, and I just drew a quick box here. Remember, we're talking all 6 sides of the box that we're testing. And the house was about 2,000 square feet, but it had close to about 7,000 square feet of surface area. So plane 2 was 1,000 square feet, 2 floors, 2,000 square foot house, but the total surface area of the box was around 7,000 square feet. So to get to 1.0, we're talking about kind of a playing card, like the Jack of Spades, that playing card versus 7,000 square feet of area. That's the cumulative leakage. 0.60, that's a business card.
Wow.
Right? To put it in perspective. So imagine a 7,000 square foot house, you throw your business card out and you're allowed that much air leakage.
That's the house. The cumulative amount of small leakage is a business card.
Yeah.
That's pretty dang good.
To put it in perspective. So getting back to double wall. So the beauty of this, you can get some really high levels. I mean, we've built walls that are probably somewhere in the R50 plus range on the wall system there. Certainly the inset there, and this here, you could also do something here where we blow cellulose or do something inside there too as an option. But the problem I have with the double wall is there is no insulation out here. And if you remember my conversation with Gus, best building scientist I've ever met, no disrespect to Joe, but he was Joe's mentor. And Gus said, put as much insulation on the outside of the wall and you'll never go wrong. So I listened to Gus. And this doesn't have the insulation on the wall and
on the outside of the wall.
On the outside of the wall. And the other thing I might point out about a double wall, if we did split this wall here, the amount of extra wall here probably accounts for about, I would say, 150 square feet on, say, a 2,000 square foot house.
Wow.
So you're adding a bedroom and putting it in the wall to do a double wall, which lends some people to come out here and throw some insulation. So that's that kind of detailed trade-off. But the beauty of that wall is the simplicity in building it.
It is pretty simple.
Right? So if you have the ability to maybe expand the building a foot, then this 6 inches doesn't matter anymore.
Yeah.
Right? So those are the things to think about.
So good, Steve. The next episode, which is going to be episode 6, we're going to be talking perfect wall and Larson truss.
These are pretty cool. These are the drag racers of wall assemblies.
This is going to be really fun. With that being said, in the words of our friend Joe Stiebrick, it's not rocket science.
It's build science.
Don't forget.
We got quizzes. We got booklets after this. So the fun doesn't stop at the vibe board.
That's right. So at the end of each episode of Build Science 301, you're going to have the opportunity to take a 5-question quiz. Answer all 5 of those right, and then go through all 11 modules on Build Science 301. And our team's going to send you a certificate that says that you passed Build Science 301. And we have that for 101 and 201, right, Steve?
There we go.
Don't forget, this is totally free. There is no charge. I think you should really take the time and make sure you get recognized for your efforts and your time. Get that certificate. This is a really big deal, and this is a good foundation for the rest of your career.
Build Science 301, a Build Original series brought to you by Andersen Windows and Doors, Arklin, and Huber Engineered Woods.